All right, hello students. It is Thursday. I hope you're having a good day and enjoying the sunny weather. So what I'm going to show you how to do today is get you started on these practice predicting properties problems that you find one in the remote learning folder. So you're going to find that here. It's in this first folder, and then it is lessons 3 and 4. We're working in this document, the chemistry packet, but we're also going to need our periodic table. So let me quickly download that and then turn it sideways so I can show you how to use your periodic table to answer these questions. So let's get into it, shall we? We're going to first talk about question 1. So now we're not talking about electronegativity or ionization energy. We're talking about other properties that elements might have. So we have element krypton with the chemical symbol Kr. They didn't know its boiling point. Sorry, it's just reading the question. So given that the boiling point of argon is negative 186 degrees Celsius and xenon is negative 107 degrees Celsius, we have to estimate the boiling point of krypton. So the first thing we need to think of is where are these elements on the periodic table? So we have krypton, argon, and xenon. So let's look around. Oh, check it out. They're in family 18. Here's argon, krypton, and xenon. So we know what argon is and we know what xenon is. Let's go ahead and check to see what those boiling points are. So argon is negative 186 degrees Celsius and xenon is negative 107 degrees Celsius. So now we need to think of where is krypton in that series. So we see argon is here, krypton's in the middle, and then xenon, right? And we see that this is a really cold temperature, so it's negative, so it's actually increasing as you go down. The difference here, negative 186, negative 107, that would be about 80. So halfway between would be, let's say, 40 degrees, right? So I would just estimate that if you increase the temperature by 40 degrees, you're going to land at about negative 145 or negative 150 degrees Celsius. So let me type that into our answers. Negative 150 degrees Celsius. Now for A. So we are now looking at chemical formulas, right? So here are the formulas for several known compounds. Using this information right here, we're going to predict the formula for a compound formed from, let's do 4A first. So carbon and fluorine, the F is fluorine. So we don't know how they'll match up. So let's look up here and check. So here's carbon, here's another one with carbon. So we know where carbon's going to be on the periodic table. It's going to be right here. And let's see if fluorine's in this row. Let's see if there are any compounds that are paired the way we have in our example. So looking here, not oxygen, but chlorine is in the same family or group as fluorine. And chlorine has 4 of them when it's paired with carbon. So that means fluorine must be the same. So we have carbon, and then fluorine, 4. What I'm going to do here, I'm going to try to make it a subscript. Let's see if I remember the command for this. There we go. So it's CF, subscript 4. And we're modeling after this example we were given because fluorine and chlorine on the periodic table are in the same family, so that makes the subscripts the same. We're going to keep learning about why this is soon, but for now, just use what you're given and try to model why that is. Okay? That is the lesson for today. I will see you on Google Meets at 3 o'clock.